Thank you very much, and thank you for joining this session. So my name is Nir Lotan. With me is my friend and colleague Barak Rozenwax. We're both from Intel, from a team called Advanced Analytics. This is a team that specializes in machine learning. And within the team, our department does a lot of deep learning projects. So in the next 40 minutes, what we plan to do is we want to share with you some real use cases we've dealt with at Intel with deep learning to solve them. And we want to dedicate about half of the time also to demonstrate and do actual hands-on demonstration on the deep learning framework. At the end of the session, hopefully, in addition to knowing these use cases, you will also see an easy way to apply them on your problems and have similar solutions based on what we show you here. So deep learning is definitely not a new thing. We've seen a lot of the applications of deep learning today and yesterday in the conference. It is not new. In the 70s, there was already an implementation in convolutional neural networks. In the 80s, we've seen the usage of backpropagation. But basically, until the year 2000, you can call it the winter of AI. We haven't seen too much progress. And if you take from the year 2000 and go jump to the last 3 or 4 years, basically there has been a huge leap in what deep learning can do. Mainly thanks to the amazing compute power that we have by the processors that are enabling it, and also all the big data technologies that are helping us create larger data sets. So if you look again back in the past, from an academic research focused mainly on vision, today deep learning has become industry standard, solving a lot of problems, including machine translation, answering questions, speech recognition, really diverse set of problems. And again, I'm going to share with you some of the problems that we've dealt with at Intel, mainly with external customers. We also use machine learning and deep learning for internal problems. So as some of you might have heard, Intel is working a lot with autonomous cars industry and recently also purchased Mobileye. And part of this work, we're definitely using deep learning to recognize objects. The car is driving, there is the camera, we're doing object detection, image segmentation, and image classification. So this is really a common use case, and I think everyone knows that autonomous driving is using deep learning. Another product that Intel has developed is a virtual headset called Project Alloy. Our CEO announced it last summer, and basically this is a headset that creates a virtual reality. You put it on, there are a lot of games you can play with it. You interact with the headset using speech and hand gesture recognition. So basically on the headset you have microphones and cameras that record your voice and analyze your hands, and we've used deep learning in order to do classification of the gestures itself. And again, we'll see how this is applied in a few minutes. There is a company we worked with that is doing product recognition as part of a smart shopping cart. So basically there is a smart shopping cart, you take it in the supermarket, you take your products, you just put the product in the shopping cart. There is an Intel RealSense camera that captures the product as it goes down. The RealSense cameras can distinguish the image from the background. So this makes it very easy to use for deep learning. And we basically use the image classification problem, a very simple problem in deep learning, in order to identify the product, and then you build up the bill as you go in the supermarket. Another use cases that we are supporting and basically using Intel tools, you can tackle this use cases. There is a Kaggle competition for trying to screen cervical cancer. So based on images taken from a sensor that the mobile ODT is providing, and there is a large data set, you can all go and log into Kaggle, and this competition, I think the time window for joining there is another week. And basically we will show you today a tool that Intel provides that basically you can take out of the box, start to apply best practice deep learning models, and start to get very easily some results, and we'll show you again how to do it, or at least some of it. And one more use case that we want to share with you is, it's called Hack Harassment Project. This is a project that a foundation, a collection of organizations, including Lady Gaga's foundation, Vox Media, and Intel has partnered up. The idea is to try to keep the online environment harassment free. So both forums and Twitter being able to also provide technological means to screen the text there and see that there are no harassment text. And also there is some educational activities around this initiative. And basically this project is using traditional machine learning. And we also are trying to apply deep learning in order to get better results and also become a multi-language. I'll speak a little bit more about this project later. So if deep learning is so popular and it becomes industry standard, what is the problem? Okay, what's the problem that we're trying to solve? And I think every time if you are able to discover the next problem, it will give you a leap to the next step. So we believe that setting up the deep learning, starting with deep learning, is still difficult. It's not just setting up the environment itself. So getting, if you want to run it on a cluster of machines, if you want to, there is a breakthrough you need to do in order to start running the models. There is the data that you need to collect and manage somehow. So this is still a difficult task today. In addition, the training itself takes days, sometimes even weeks. So you want to accelerate that. And obviously you can buy accelerators, you can scale out and run it on multiple servers, but this is still difficult to do. And also we believe that not enough people have the expertise to run deep learning. Now, I'm not looking for that everyone will be researchers that invent new topologies and new networks, but we want more people to be able to apply deep learning in practice and solve problems, and they don't have to be data scientists or software developers. And I think this is really important in order to advance and have more use cases. And this is why we came up with the Intel Deep Learning Training Tool. So there is one marketing slide here, and then we'll demonstrate some of the use cases using the tool. Basically, this is a tool that was developed in order to make it easier to run deep learning experiments. And the value that we propose is basically a very easy way to start with deep learning, to set up the environment. I see a lot of you have Macs here. You can basically go to this link, download the tool, install it on your Mac, and by the end of this hour, you will be able to run the tasks that we show you here on your data sets. So in a very easy to use installer, it will provide you a full environment with multiple frameworks. So now we support Caffe, TensorFlow, and Keras, and they are optimized to run on Intel hardware. And also we provide a layer of cluster management. So if you do want to install it on-premise or on cloud on a data center, you have a very easy way to manage distributed execution of deep learning training. So that's the first value. The second is we provide several user interfaces. So you can work directly with a framework, as you usually see in talks like here. I think the previous talk showed us how to work with TensorFlow directly. But additionally, we provide a very easy to use step-by-step wizard, a graphical user interface, which is very useful to run your initial experiments with deep learning. If you have new data sets and you want to apply, run fine-tune on your own data or apply your own data on known models that are known to solve specific problems, so you can do it with the wizard. And also Jupyter notebooks that can provide and show you the actual code if you want to customize it and move from this wizard to the framework. And the tool supports image classification, image segmentation tasks. We provide examples on how to do it, document classification, and also data auto-encoding. You can run any task that you can run on the framework, but these are tasks that we actually provide the sample and show you how to use them. So now we want to cover two problems that we were trying to solve using the tool. And the first one I want to talk about is the multi-node training. So basically, if you remember the use cases I showed to you, most of them were image problems. And with the amount of data that we have, basically it takes a lot of time to get your results. You want to get the results faster because it takes time. You want to compare some others. So we wanted to scale out and run on multiple nodes. The problem is that it's quite challenging. If you take the known frameworks, they all support multi-node training, but it requires another gap in knowledge that you need to catch up. So what we did is basically we took and created a solution that is deployable through the tool. We used it ourselves, and you can use it as well. From architectural perspective, what we did is we're using Docker containers. Each Docker container, even for the single node, we're using Docker container per framework. And then we have a wrapping layer, provide APIs, and on top of that, you can log into the tool using the browser or the Jupyter notebooks. Now, for multi-node, we are also using Kubernetes to do the cluster management. So basically, when you install the tool, you get the top part here. You get the first thin layer of our deep learning tool service and the Caffe service and TensorFlow service. And using a Jupyter notebook, you can create additional nodes and basically create your own cluster. Adding additional nodes with one single command line and basically also do the training with a very simple to use API. So I'll switch over to my friend Barak to show you in practice how this is done.
Thank you, Nir. So just 1 second, it will be up. Okay, so what we see here, just a second. Okay, what we see here is the user interface that Nir talked about. I'm not going to cover all the user interface right now. I will do a quick brief so you won't have a question about all the left panel menus and everything. So you will have an idea, and then we will jump into the multi-node example. So like Nir mentioned, the user interface is really easy to use, and I will demonstrate in the second part of the demo the next parts. But this menu here basically covers the flow of any deep learning run that the user needs to do. So we start with the home page is just for showing notification and showing how active objects are running and so on, and also provide quick links to the different actions that you can do inside the tool. The upload section is for uploading your raw data to the server if you're working on a server, or to the Docker if you're working on a Mac locally, for example. So this is an important step you need to do to bring the data in order to digest it and create a data set, which is the next one. The next step here, of course, is the model configuration, the model run. We will show it afterwards. And where you get the model, you can view it, you can view all the information about it. Another tool that we added to our training tool is a compressed model. It's another step that you can do after you train the model, and you can transform it and make it smaller so you can use it in applications that require less data usage. And the part that I'm going to focus on right now, it's the advanced section, or basically the Jupyter notebook section, that allows us to do a lot of things. So you can see here that we have two different subsections, one for Caffe and one for TensorFlow. These are for the two frameworks that we have. So we have different repositories for handling different tasks according to the framework. So I'm going to talk about the cluster management, the multi-node that we have. One more thing to talk about the notebooks. We have, let's say, 3 kinds of notebooks. One of them are for customization. We will see it in the next example of the training, how you can customize things. It's also a tutorial notebook, so you can learn from it. You can just customize it and then use it for your own purposes afterwards. And the third kind of notebooks that we have, like this one, is for cluster management and data management, and that I will talk about in a minute. So when we created the Intel distributed Caffe library that is downloaded inside the tool when you get it, we thought about that our target is to provide easy to use APIs so users can create their cluster, meaning that they will be able to add the nodes, remove nodes, check their status, understand how many nodes are available in order to run the training and so on. And you can see the result in the notebook that we have right here. Okay, so as you can see, these are very simple to use command line that you can run. Right now it looks like we have a problem in the network. But the APIs are very easy to use, only need to provide a small amount of parameters, like for example, in order to create another node and to download it to it, all the Docker images and everything, you just need to provide the host IP or the DNS, the username and password for the server, and this is it. Everything will work from the notebook. You will get all the information you need, and everything is really easy to use. And the important here is that even new users or people that are not that familiar with clustering and deep learning and so on can really run it easily. Now I will switch over to the Caffe multi-node training tutorial. Again, you can see that the training notebook is very nice to read. It has a lot of information. You can see all the different steps. I will go over it briefly so we can see what it means that you can customize it and run it. I'm not sure if it will run right now because it looks like we have some kind of a network issue, but let's try to do it. So you can see that the code inside the notebooks is code as I guess most of you are familiar with, and if not, you have all the information you need in order to understand what is written inside and understand how to run it and what you will get at the end. Let me try to run it and see if it works. It looks like it's working. So right now I'm importing all the libraries that I need and creating all the folders that I need in order to run this example. Next step, when I'm going to run the multi-node training, I need to prepare my dataset. It means that I'm going to download it from the internet. We're taking an example called CFAR10. If you're familiar with this dataset, sorry, it's a dataset with 10 classes of animals and cars and all kind of that. So with this command, I simply download it to the server and creating the LMDB dataset, which is the dataset that I'm going to use afterwards in the model. Next part is that I'm going to copy the information to the dataset and the LMDB, sorry, to the example folder that I'm going to run from. And I'm going to divide it into the different clusters as well in order to run faster and not have network issues when I'm running on the dataset. So training preparation means actually that I need to set all my parameters. Okay, so you can see here the solver file and the train file and all kind of stuff. I'm not going to dive into it so much, but we can see an example in a second. I'm just configuring everything. Okay, here you can see an example of the solver file. Just one session before us, the guy talked about the learning rate and everything. So you can see here the learning rate and all the different parameters that we need in order to run the training. So we have it from a file that, of course, is also part of the tool. And I just edit it to or configure that this will be the file that we use. Same thing for the topology, okay, the structure of the net that we are going to use. This is the file that we can see here. And then basically we are ready to start our training. Right now I'm configuring the folder that I'm going to run from, okay, and I'm, like I said, I'm copying it and distributing it to the other cluster. I'm going to check how many nodes do I have available. Right now I'm working on 2 nodes, 2 different servers. One of them is the main node and the other is the worker node. And this is a really important stuff. I'm going to, although I'm working on 2 servers, 2 nodes, I'm going to have 1 log file that will be stored in the main node, and then I will be able to track it and see the progress and understand how is my training going on. I'm defining an execution name for the training. Okay, right now it's a CFAR10 tutorial, and then this is the real action that I'm going to execute. You can see that everything I done was basically getting things ready for the execution, and the execution itself is a pretty easy to use and easy to understand API. I can just start to run it, and it gives me information about 2 nodes that were allocated, all kind of information about the parameters that I have set before. Now I'm able to see if the job is really active, and I can see the CFAR10 tutorial is active and where the log is located. I can also have the history of the jobs and all kind of information that I can retrieve from the APIs that we have created. Now if we want to examine the output and see how things what's the progress, so we can see the log and track it and see what is the accuracy and so on. We can also see it in a graph. Okay, so right now I'm copying the log file into different parameters, and I'm going to try and plot it. Sometimes if it's too early in the process, I can have an error like I'm seeing here, and the reason for it is because the number of iteration is still didn't reach for the first snapshot or the first model to have, so we don't have the accuracy yet, but you can see the train loss is going down and progressing. I'm not going to cover the rest of the notebook, but in general you can then take this model that you have or a snapshot from it and fine-tune it, meaning that you can use the trained model with the pre-trained weights and then get a different data set and run for it with the small number of iteration and so on. So everything is available in these notebooks, and we have all kinds of notebooks like that. Really important to say that right now I'm showing an example on Caffe. We have the exact same thing, only of course a different notebook for TensorFlow distributed as well. So like I showed before, it's in a different repository, but you can run TensorFlow distributed on our tool as well. Again, same idea, different commands of course, different Python code. And that's it for now, Neil.
Thank you, Barak. So thank you. This was really nice to see it live on stage, running distributed execution of training. The next use case we want to talk about is the text use case. So we've seen training of images. The text use case that we want to talk about is, as I said before, is this project that speaks against online harassment. This is an open project, so this is also something you can join. The idea is, the effort is to try to make the online environment more inclusive and more supportive. So the idea is to try this organization has a lot of educational activities, but we're also trying to provide online tools, tangible tools, technological tools to reduce the frequency and severity of online harassment. So the project is using traditional machine learning, and usually with text, traditional machine learning is much easier than deep learning. Setting up deep learning for text is harder. It also requires larger data sets than traditional machine learning. Think about harassment. It's very easy to just say a few words that if they are part of the tweet or in the form, this means that this text could be harassing someone. So what we did is we tried to apply deep learning here. And what we did for this specific solution, and that's the idea behind the tool, we're trying some use cases. We are deploying them as part of the tool, and you can take the solution and apply it to your own text. And what we did is based on a research done in NYU by Jan LeCun and two other gentlemen. And that's basically character-level convolutional networks for text classification. And in this, the idea is to treat text as a vector of or raw signal of text characters at the character level. So we're not looking at it as a word by word, like word2vec is a known solution to that. But basically we're taking the sentence at the character level, looking at it as one signal and applying one-dimensional convolutional network on that signal. And let's see how this is done. Now, basically you can see also the code of this in a Jupyter notebook, but Barak is actually going to show you how this is done in our interactive user interface. Go ahead, Barak.
Okay, so again, I'm going back to the user interface. This time we're not going to talk about the notebooks and the codes. I'm going to show you, let's say, the simplified way to do it. So again, as mentioned before, we have TensorFlow and Caffe. Right now, we are supporting two different tasks through our user interface, and you will see it in a minute. It's image classification on Caffe and document classification, which is the example that Nir talked about right now in TensorFlow. So what will be the first step that I will need to do in order to start running the model or start integrating with the problem that Nir talked about? So it will be to upload the data into the tool. So we have information for the users saying that if you want to run a document classification issue, you need to upload a compressed folder that is compiled with 2 or 4 files. The first one is the label file. You can see the category name. So in the data set that Nir mentioned, we will have arrestment or no arrestment. This will be a 2 category problem. And on the data file, which is a CSV, you will have 2 columns. You will have the category ID and the text, the tweets actually. Okay. Next, we will see in our dataset creation step that we can take this file. Okay, I'm opening now the wizard for the document classification problem. You can see that we can take this file, select it here, okay, and we can see all the CSV files that are inside of it. What does it help us with? So we can either take one big CSV file, which will cover all of our data, and divide it by percentage into train and validation. Or we can take, for example, one train file for the train, and for the validation, select the test file of validation, and so on. So this is the first steps of the wizard. You can see it's very easy to use, very nice for just clicking and proceeding and experimenting with this data set. The second part is the pre-processing. Again, in text, we need to define what is the number of characters that we are going to use and what is the dictionary. What are the characters that we want to live inside the data set. Of course, it differentiates between the different tasks and so on, but this is the next step. After I'm finished with that, I will be able to run the data set. Okay, this is a different example, and get the overview of the data set. Here you can see that we don't have 2 classes, we have much more. Okay, this is a data set called DPpedia, and you can see that there are a lot of classes. You can see the number of documents, you can see how many validation for training, information about it, all the text pre-processing, and so on. And the next step, as I mentioned before, will be to start basically the model itself. So I can go to the model step, the model menu, and again, the same thing as I did before, start to create a document classification. Those of you who are sharp and not full after lunch can see that it's pretty much the same wizard. It looks pretty much the same, only the content inside is kind of different. Again, it's very simple to use, and the flow is logical. Okay, so when you want to create a model, you need to select what is the data set that you want to use. We created it before. You select what is the topology or the algorithm or whatever you want to call it that you want to use. Again, right now for document classification, we have the character level convolutional network. And then you reach to I would say, the most important part when building a model, the parameter. So like I showed you in the multi-node, we have different solver files and so on. Everything here is front end, so you can define all the parameters and everything you need through the UI. So first of all, it's easy to configure. Second, we offer you the parameters that are optimized. What does it mean? The parameters that are either optimized for Intel. I will show it in a minute in our image classification problem. It's easier to understand there. But are optimized for Intel mean that it will run faster and it will give you the best accuracy it can. And second, it's already provided to you. So if you are a new user and you don't know exactly what you want to do, or you want just to start and play with it in order to understand, we give you the information you need in order to start and get result. Of course, that afterwards you can see the result and tune it and so on. Again, base learning rate, the batch size, the training epochs, and so on, everything is shown here. After we start the train run, so we start the configuration, we have a model that is added to the model menu. And here you can see the real value, I think, of the tool. Sorry. A model in our tool comes already with all the information you need in order to track it. You can see what is the epoch number or the iteration, what's the current accuracy. You can see the train loss, and the best learning rate, which is the blue line here. You can see the accuracy according to the different snapshots that you have done. And you get all the information you need in just a few clicks in one installer that is very easy to use. And all the dependencies and all the libraries you need to download in order to run deep learning, you get it as a one package in our tool. Not just the information you can see here. You have different information here. I'm not going to run by each one of them, but in model analysis, you can see a confusion matrix. For example, if we're talking about harassment, not harassment, you can see the number of images that were labeled as harassment, what part of them is a true harassment, what part of them is not. In the dataset, you can see a deeper dive of the data itself. Okay, so you can see a snippet of the text, what was the label, the original label, and what were the prediction. You can filter it, and you can do you can understand deeper information about your data and how the model how the accuracy is really into the details. Where are the problems, if there is a specific label that is problematic, and so on. Testing is the place where you can take the text and basically inference it. You can put it in, click the test button, and see information about the prediction, and you can use it to, again, evaluate the model and understand if it works for you or not. And again, like I said before, in the information section, you can download the model that you want and take it over and use it as a normal Caffe or TensorFlow model. So this is pretty much the tool. I do want to share another nice feature that we have for the image part of the tool, okay, not the dataset. I will start, not the document, sorry. I will start with the image dataset. So like the pre-processing that we have for document, which is basically just the number of characters and the dictionary. In image, we support different pre-processing. The first one of them is the image augmentation. It helps you to visualize and copy images in your data by rotating them, zooming in, and so on. And so you can get a more balanced data if you have an unbalanced data, or you just want all your classes to be at the same amount of pictures. And also, I want to show that the image processing, again, is very, very easy to use and intuitive. So if you need to define what is the color of your images, what's the size of them, if you need to do any kind of reshaping, it's very easy to understand and select what are you doing here. And again, just in a few clicks, you get it. For the model part, just one second. For the model part, we have a kind of more sophisticated topology section. I will quickly go over it. You can see that we have 3 different tabs. So we are taking the topology, the image classification topologies, and we divide them by 3. So the first one is optimized for Intel hardware. Like I said before, it will give you the best result with the predefined parameters that we have added. You can also download a model from the web and then use it for fine-tuning. Okay, again, like I explained before, you can do it from the tool. The common topologies are topologies that are widely used, so we offer them as well. And custom topologies are topologies that you can edit. Okay, so if, for example, I will take AlexNet, I can push the edit button, or I can push it, but it won't work, but never mind. And you can basically edit the topology. So again, very nice tools for new users, but they can advance and start to work on that. That's it. Never mind. It's okay. Okay, it's because I didn't select the dataset. Now it will work. Okay. So this is the edit of the topology. You can see the prototext, and you can edit it, and also visualization of the of the net, which is again helps you to understand what you're doing actually. Okay, so just this one. So coming back to our tool, and after we see the demo and everything, let's talk about what next or what you can do with this tool. So first of all, you can join our community. And you mentioned it, and I will say it again, it's a free tool. You can download it. It takes about 15 minutes to install, very easy to use. We have already thousands of users. So you can download it, use it. If you have a Mac, you can use it locally. It's very nice. After you download it and review it, you can provide us feedback. We have a forum. You can ask whatever you want. You can suggest anything that you have to offer for us, any notebook, new notebook that you want to add, question about notebook, anything, you can do it there. We have cards here with all the information and this URL that you can take afterwards and go to our download page and use it. And number 3 here, stay tuned. We are releasing a new version every 1.5 or 2 months. New features, once you download the tool, you get a notification when there is a new version. You can go in and download the new version. I think that's it. So thank you very much. If you have any questions.